Hello everyone, I'm Rukma and I'm from NetApp and I'm from the Advanced Technology Group. We report to the CTO. So Dexter. So this name was actually inspired from the cartoon series, if anybody remembers, the Dexter's Laboratory. So that's the Dexter. Yeah. This is the first thing that we wanted to do in our team, and then we thought this is an appropriate thing of naming it as Dexter. So what is this about? This is about faster troubleshooting of misconfigurations using system logs. Yes. So we start with misconfigurations. Why are they a big deal? So even a Firefox, a simple application like Firefox, has nearly 2000 configuration parameters. If you take it further to something like a LibreOffice, it has close to 36K configuration parameters. So why do misconfigurations happen? So just having a lot of configuration parameters may not be the primary reason, but there are other things like what kind of capabilities are you enabling in your environment, and how do they play with the final environment that you have, the type of clients, the type of setup, and all of that becomes a complex interplay, and that leads to something called as misconfigurations. Now this is from the customer endpoint, right? The misconfigurations cause business discontinuity and losses. But even from the storage provider, right, the misconfiguration relates to cases, support cases. And the operational cost, a large amount of it, about 60 to 80%, we can average it to 70% of the costs are people costs. And we have done studies of about thousands of cases in NetApp for about a period of 1.5 to 2 years. Right? And we gather a lot of insights on how does the people cost matter. And then we went ahead and read a lot of papers from our peers and other industry players, and they also had a similar problem, right? And the two things that I chose to talk was the one of them is change of hands by escalations. That is when a case gets open and the support engineer is assigned to it and he's trying to figure out what happened. He discovers something and realizes that it requires a different kind of expertise, and then it goes to yet another support engineer, and then he finds out few things, and there's chaining. So that wastes a lot of substantial important time, which is a business time for the customer and also for the company. Secondly, communication logistics. We are talking about misconfiguration across geography, where the customer support might be in India and the customer might be in the US. So time zones, communications, getting the data, customer giving a clarification, a lot of that eats up a lot of time. And we wanted to ease this whole workflow in NetApp. So this is an example to just help understand what a typical misconfiguration looks like. So if you look here on the left hand side, these are this shelf IDs which have been configured by the customer. The third entry looks quite suspicious, right? And this could be a cause of a misconfiguration. Now if you look at the system logs, basically we could call this as a digital exhaust of operations that the system is doing. We see that there is an error message which says there is an invalid shelf ID. Right? And of course the resolution could be that this needs to be a numeric address where there are 4 numbers and they are separated by periods. A simple fix to it. So what we intend to do in Dexter, in fact we did it, and this has been working in NetApp's support data center, is provide these 2 steps, right? Provide some clues into what might be there in the system log that indicates the problem that the customer is undergoing, and what could be the resolution. Of course, the resolution on this slide is quite straightforward, but we talk about resolutions which are more like commands, right? Enable signing in SMB is a simple resolution, but how to do it? What is the command? Where are the parameters? So those kind of things are sometimes even harder to find. So we kind of hope to enable or faster that thing. So Dexter here, and the Spotlight again notion is derived from that thing, is we want to provide 2 types of clues to the customer or the support person who is handling the case. And this is based on this notion called as ONTAP auto support. So NetApp has this information source which is called the auto support. That is, every customer which buys NetApp sends the information about how the system has been operating, its logs, its performance counters, its configuration data back to us. And these are actually curated and transformed and stored inside NetApp. So we leverage, this is kind of our data source, the auto support, and using that we derive 2 things. One is called as the problem spotlight. if you could relate this to the previous slide, it said invalid shelf ID, right? So what are those ranked list of system logs which might be useful for a person who is handling the case, help him resolve the problem. And the second aspect, which actually kind of completes the puzzle, is the resolution spotlights, which is again approach based on heuristics, which says that I have looked at customer executing all of these commands, right? And around the time when the problem got resolved, I saw the customer acted on this problem by this command. Can I derive this programmatically using text mining, and can I give it back to the person who is solving the case, which would be similar in the future, right? So this is about the resolution spotlights. So let me go a little bit in depth about problem spotlights and resolution spotlights. So starting with problem spotlights. So when we talk about system log messages, they have a whole bunch of metadata. When was the message created? What was the timestamp? What was its severity? And a lot of other things, right? And the core message which talked about, let's say this shelf ID is invalid. So in Dexter, we use these metadata things as features, and timestamps and the module and the error message and so on. Now let's look at this from the pane of a sample error message in Apache server, because this is something that everyone could relate to. So this is the error message, and if we had to color code this error message with what features we look at, we see that there is a timestamp, there is a module in Apache which developed the message. The severity of this message is it's an error, and there is a message which says what has actually happened, right? And this message can give the user or the problem, the technical support engineer a clue that maybe this file is not available, maybe it's in a different path, maybe the directory doesn't exist, but it got to do something with correcting this problem. So there are more details in the paper, but the way we use these metrics is in these three ways. So we look at these three metadata items. We look at what is the recency of the message, that is when did a particular message in the system log appear. We don't know, of course, which message is important. We look at all messages and then kind of rank them on the basis of their recency. The idea being here is the problem which the customer is facing, the error message would be somewhere correlated and temporally co-located with that timestamp. So recency is important. Severity is of course important, because if the message is informational or warning type, it might be less important than a message which is saying it's critical or it's emergency and so on. And the third thing is message frequency. This is more got to do with how often the message has been showing up, the log message or the error message, whatever has been showing up in your logs. The idea is that if the customer has been using a particular feature and is not able to get it work, those messages must be coming more frequently for that period of time than they might have appeared during any part of the time, or may have not appeared at all. So these three metrics are combined in a simple way in the paper to come up with a ranking for every message that is appearing in the system logs, and then they are scored and they are ranked. So these log messages which are ranked and which Dexter comes up as the top rated messages are then presented to the support engineer for further analysis, and that might help in root causing or troubleshooting the problem. So the next item for Dexter is after finding the problem spotlight is the resolution, that is what was the command or how was the problem solved. So as I said, this is a completely heuristically driven approach. So what we do is we ask Dexter when a case is opened, what are the right list of messages you suspect to be correlated with the problem that the customer is undergoing. And then after the case is closed, that is the problem is resolved, we go back to the same system and then try to figure out what are the new spotlights coming up. And if one or more of the earlier appearing spotlights have disappeared, that is they no longer exist in the system, we can say that maybe these are the ones which are causing the problem, and since the problem is resolved, they have disappeared. And now what we do is we go back to the second source of data, which is the commands. So we also have commands which the customer executed. Mostly they are management commands. system management commands. So they are also available through auto support. We look at those commands and see which of these are temporarily co-located with the time when the messages disappeared. So what kind of messages commands we look at? Any command which is new. So a particular command was executed first time around the time when the case got closed. Or a command which was earlier also executed, but this time it was executed with a new argument or a new value to the argument. For example, customer was always setting timeout for the shift setup, and suddenly the customer changed the value of the timeout, which was always, let's say, set to 1 hour. Now it has been set to 24 hours. We put a suspect on that particular command to be a resolution. So this is how the workflow looks like. If you look at this, this is a misconfiguration support case being opened. So there are two phases. One is the online phase, where as soon as the case is open, Dexter is intimated about it. The Dexter pulls in the system logs for that particular system. And of course, there is, as we mentioned earlier, there is a process of figuring out what are the features, the metadata related to the logs. These are extracted, the features are extracted. And then there is a ranking scoring algorithm which uses those three metrics, combines them, and then says out of this, let's say 10,000 messages, this 10 messages are very important and they are ranked from order 1 to 10. And now these are published onto the portal, which the support engineer looks at when the person is handling the case. So these are like the clues of the problem. So this happens on a continuous basis. Every half an hourly, Dexter polls for new cases, publishes this problem spotlights. The offline mode is when a case is closed. So Dexter also polls for cases which have been closed on a day-to-day basis. As soon as the case is closed, what it does is it pulls out its published spotlights, and then it pulls out the new logs which are generated by the system and sees whether any of these top 10 here are missing here. And then says maybe they have disappeared. So maybe that was causing the problem and they have disappeared, and now pulls out the commands which were executed on that system for that period of time when the case opened till it closed. And you might get about hundreds or 200s or even thousands of messages, the commands which got executed. Now it tries to correlate the timestamps when these commands are executed with the timestamp when these messages actually started disappearing. So let's say this message disappeared on 14th of July at 3 p.m. and this command was executed on 14th of July at 2:45 p.m. Then it knows that maybe this has caused this disappearance. So this could be a potential spotlight. And now this curated list is published as a corresponding command to the problem spotlight. And this is what we have been storing in a signature database that we have created, but is not yet online, because we need to validate this entire database before we hand out this database to the problem, the support engineers, so that they can look at the spotlight and say this is a solution. Look at the spotlight and say this is a solution. So that is an ongoing process, but this is what we have done in the Dexter. So there is a long process of validating what we have done, because it's not easy. So the customer's problem was fixed, and there is a portal where the person who fixed the problem needs to say how was this problem fixed, right? But there is no norm for it. The best practice is to enter what problems it got and what solution it was applied. But in the worst case, the customer might just leave a note saying that this problem was a SIPS problem and it was fixed. So there is no way to figure out what we actually got was correct or not. So what we did is we went through a sample set of 600 cases which were manually validated by us. Take each case, go to the portal, see how it was fixed, see what we have got, and try to correlate. Sometimes we seek an expert advice like, does this make sense? And that process gave us these two graphs. So the first graph is about problem spotlights, and this is the percentage of cases. So total number of cases is 100%, which is 600 cases. If we see 30% of the cases, the problem spotlights that Dexter published, the top 3 spotlights had the clue. And so on, for about 92% of the cases, we were able to find the exact problem causing log statements for within the top 8 ranked log messages. And of course, there is always a reason of not finding something. There could be many reasons, like you have not found the logs, or the logs were not shipped properly, or they were not curated properly and they are lost. So barring all those sides, we have a good success rate of finding those. Now when it comes to resolutions using the heuristics that we mentioned, we see that again 100% of the cases, for 20% of the cases, there was only one resolution that Dexter pointed out, and that was kind of spot on. So this is what customer did, this is what we showed, and that can be used for future reference, right? And for about 65% of the cases, we were able to find this within the top 3. So on and so forth. So this is how we validated the entire mechanism. So this is what I had for Dexter, and any questions that you have for me?
Questions?
Would you consider re-injecting the suspected problematic commands so that when you take them out, it seems to go away, you put them back in, and the error messages show up again?
So that's a good question, but we don't, basically these are field tested things. I mean, the customer does something. So the inputs are not generally available to us, and yeah, so it's hard to validate.
So which kind of algorithms did you use to do the correlations, or just countings?
So for now, we have been just using simple statistical approaches, no standard algorithm as such. Like these are all temporal correlation based things. And we use a graph kind of a representation. So the paper has more things on, each command. For example, we break the command. So the command is broken into a command prefix. Like for example, SIF server setup would be a command, right? And there would be arguments like, volume name and the timeout and the signing, and these are all arguments. So we kind of break it into the node structure and associate timestamps and the values to each one of them, and kind of do a graph traversal algorithm to figure out when did the values change and kind of temporally correlate them with the log messages.
What are the amounts of logs that you are able to
It's huge, so it goes to millions sometimes, and it also
millions
depends.
of lines?
Yes, million lines of logs, and there might be like 100,000 to 20,000 unique log messages, because some of them keep on repeating. So it's the way the system is baked in. Some of them are like regular logs, some of them are like once in a time kind of things.
Did you use any big data tools, or just?
For this, no. For this, we didn't use a big data, but then the later part of it, we have been now using the Hadoop and other associated tools. Yeah.
In theory, the software should prevent, users and administrators from making silly mistakes. How many of these have been looped back to the software people so that they can fix stuff to avoid the problem in the first place?
That's a very good question. So the same thing, that is, the system should prevent customers from doing something wrong, or should come back to the customer saying that this seems to be wrong. So there have been various ways in which things are happening, but this Dexter has been used as a mechanism to feed it back to the development group, saying that even the log messages are missing, or sometimes the log messages are not very clear. 2 or 3 problems could actually generate the same log message, right? So all these kind of efforts are now being driven. Yes.
So when you detect a problem, you have to make a decision whether it's a configuration problem, a hardware problem, a transient problem, and so on. Otherwise, you get a lot of noise.
Correct.
So how do you handle this?
It's a good question again. So if you look at the way Dexter gives messages, right? Some of them are actually related to the problem, the exact problem that the customer asked for him. But some of the messages are actually hinting for a problem that maybe customer has even not looked at. That's one way of it, right? So what we do in Dexter, if you see, we kind of have left it to the support engineer who is fixing the case to decide whether it's a problem or it's just a mismatch in expectation of the customer. That also happens often, right? Or it is a performance problem which is more to do with the way the system is being used and not the way by which it is set up or a configuration. But of course, the natural step later on is to kind of, draw these boundaries or segments and say, this is performance, this is configuration, this is, the system performance objective setting. So all of that.
Any more questions? Okay, let's thank our speaker again.
Thank you.